Okay, so there's our first if statement. General form of the if statement in C++ is right here. You just have to replace the condition with a logical expression. Logical expression just being an expression that when evaluated turns out to be either true or false. And then you put your statements here. Okay, so about indentation inside an if statement. Convention is, very strong convention and good practice is that we indent the statements inside the if statement one level. In Python, you have to do that, right? Or your program won't work. In C++, you don't have to do that. The compiler doesn't care, but we do it so that other humans can read it more easily. Let's see, what else do I want to say about this? Open and close curly braces. So, the rule in C++ is that if there's only one statement here, you don't need the open and close curly brace, right? So a lot of programmers like to do that. If there's only one statement in here, they will just leave the open curly brace and close curly brace out. Personally, I like to just always use the open and close curly brace. I think that makes my code just more consistent. You know, every time I see an if, I can always just go down the margin and I can find the closed curly brace. Also, one could argue that this might be less error prone in case you end up going back later and you have to add a statement inside the if. You might forget to put the open and closed curly brace in there. So anyway, that's my preference. If you prefer not to use open closed curly brace, if there's only one statement in there, that's your choice. I'm not going to make you use the open and closed curly brace. I do want to point something out though. Let's look at this example down here at the bottom for a second. In this case, it's important to notice that statement 2 is not part of the if statement, right? Even though to the human eye, it may look like it. And especially if you're used to programming in Python, there's going to be a very strong inclination, I think, to assume that this statement 2 is part of the if statement, but it's not. So in other words, if hours is less than 40, is statement 2 going to get executed?
No.
Okay, let me actually back up a little bit. Okay, if hours is less than 40, is statement 1 going to get executed?
No, it won't.
No.
Okay, so that's correct. Statement 1 only gets executed if hours is greater than 40. Okay, how about statement 2? Will statement 2 get executed if hours is less than 40?
No.
No.
Okay, so statement 2 is not part of the if statement, right? So here's the if statement. So if hours is less than 40, what happens is I say, okay, hours is less than 40. So that means I'm not going to execute the statements that are inside the if statement. So I'm not going to execute statement 1. So now I'm done with my if statement. So now I go on to the next statement after the if statement. The next statement after the if statement is statement 2. So no matter what the value of hours is, statement 2 is always going to get executed because it's not inside the if statement. That makes sense or not? Good. Okay. Anybody want me to talk about that some more? So the problem here, the issue here that we're dealing with is that this statement 2 is indented incorrectly, right? It's not indented correctly, but the compiler doesn't care about that. It's just confusing to us, the readers. Okay, so just if you're not totally sure about what we just talked about, make sure you go back and look at this in the lesson. Make sure you get that figured out. That's pretty important. I'll also just throw throw out there that this is sort of a canonical exam question, right? To make sure you understand what happens if the curly braces aren't there. So just make sure you get that. Okay. Besides indentation and whether or not to use the open and closed curly braces, the other thing we should talk about is where to put the open and closed curly brace. The system that I like to use is as you can see, I always put the open curly brace at the end of the line after the if, and then the closed curly brace goes on the margin, or not right below the if. I guess margin isn't quite the right word, but it goes directly below wherever the opening if was. In the textbook, and honestly, I think pretty much in just about every introductory textbook I've ever seen, they like to drop this open curly brace down onto the next line. I don't have a picture of that, but hopefully you understand what I mean. Actually, I guess I can just, anyway, you'll see that in the textbook. You can choose either of those systems you like. My experience is that for whatever reason, most introductory students like to see this open curly brace down on the next line. But in my experience, probably 80 to 90% of the more advanced programmers or professional programmers that I have seen like to put the open curly brace up here. Just turns out to be more convenient in the long run. All right. That's all I'm going to say about that. Basically, for this class, I'm saying there are two different systems you can use. You can choose to use the system that you're going to see in the textbook. You could choose to use the system that you see in the lessons, but you're going to have to choose one of those two. Whichever system you use, the most important point is right here. It should be always easy to tell whether you have the correct number of closed curly braces, whether they're lined up correctly, right? So in my system, I can always tell if everything's kosher just by looking at the if statement and going directly down the line to see where the closed curly brace is. If I see this in my code, I know there's a problem, something's wrong. If I see this code, I know there's a problem. Just by looking at these last two, I know there's no possible way that that pattern could be correct. There can't be a closed curly brace and then another closed curly brace that's indented 2 fewer levels. So I don't expect all of that to make sense necessarily at this point. I just want to make sure you understand that if you're using a good system, this should not be an issue. You should be able, if you find yourself looking at your code and spending a lot of time just kind of tracking where the open and closed curly braces are, it probably means you need to work on what sort of system you're using, because it shouldn't be that difficult. Everyone okay so far? All right. Okay, if else statement looks like this. I'm just going to skip down. Looks like this. And basically it just means if the condition is true, then execute this. If the condition is false, then execute the else part. You've seen that in Python, so I'm not going to belabor the point too much. Any questions about if else? The one thing I will say is that in Python, there's something called elif. There is no corresponding structure in C++. So instead, you just use else, and then you put another if statement after it. So just to give you an example of that, we've got this right here, right? If the score is greater than or equal to 90, see out A, else if score is greater than or equal to 80, see out B. In Python, this would be a special construct, right? elif, if I'm remembering correctly anyway. In C++, there's not a separate construct for that. You just say else, and then you follow it with a separate if statement. So basically, excuse me, basically what we're doing here is we're temporarily suspending the rule, the very strong convention that every statement should start on a new line. And just to make this work better, we're going to say in this one particular case, it's okay to have an if statement that starts right after the word else, because otherwise, if we follow the rule about every statement starting on a new line, we end up with something that looks like this. This is the same code, but obviously much more difficult to read than if we just line it up like this. All right. I think that's pretty much all I want to say about if and if else statements. Anybody have any questions before I switch gears here? In C, excuse me, in C++, there's also something called the switch statement. I'm not going to take time to go over the switch statement. It's pretty, what's the word I'm looking for? It's there's nothing conceptually difficult about it. It's just another structure to learn. You can read about it in the textbook. So we're not going to take lecture time up that. Everyone's happy? Okay. I think I'm going to switch to now, I'm just going to keep going through the lessons like this just because I know you guys already know about loops from the previous class. There's not that much different. So let me just switch to the next lesson here. I actually need to take like a 3-minute break here. So if you'll bear with me for just a second. I'm going to pause recording and I'll be back in a couple minutes. All right, we are back. I think I decided that during my little break that I'm actually going to just show you the result of using the command line and a text editor. Particularly those of you on Mac may decide you want to do this at some point if Xcode is giving you some trouble or something. I do it because my Mac is a little bit on the old side and I don't have enough hard disk space left to install Xcode. Anyway, hold on. Let me get some code up here that we can look at. That is not what I wanted to do. That's better. So I want that to. All right, so here's a while loop. This is basically, you can see that we've got the core of a program here that calculates someone's paycheck given the hours worked and the pay rate. I will say that if I were doing this again, I would probably make this make these variable names a little more descriptive. With all of them. Anyway, we'll go with that for now. And let me save this. Let's call it. All right, so here's the core program, and I've decided that I want to improve my program by making it repeat over and over again, so I don't have to keep running the program again each time I have a new employee to process. So you can see that the syntax for a while loop is simply, it's exactly the same as the syntax for an if statement, except that I use the word while instead of if, right? And so if this condition is true, I execute all the statements inside the open and closed curly braces. When I get to the bottom, I go back up to the top again and I check the condition again. If the condition is true, I execute everything inside the loop again. When I get to the bottom, I go back up to the top, check the condition again. When the condition is false at that point, then I go on to whatever's next in the program. In this case, that would be the end of it. Any questions just about the basic format of a while loop? Okay, here's what I want to do next. Let me just do some typing down here. I want to change this so at this point, if I run this program, actually, that's not a bad idea. Let me just run this so you can actually see what's going on. I'm going to have to share my whole window, whole screen. So if I go to my command line now, so on a Mac, this is called the terminal app that I'm in. And I'm going to say, is that big enough? Someone feel free to chime in if that seems too small. I can always make it a little bigger. If I say G++, and then the name of the file, it's going to
not have an error on line 19.
Yep, I do. H hours. Hours. There we go. All right. So another interesting thing about doing the command line is you get to see just a little bit more about the details of what's going on, right? There's actually a two-step process going on here. The first step is I am compiling this, which means that I am converting the C++ code into machine language, right? And so I'm creating an executable file. By default in Unix, if I don't tell it what to name that executable file, it names it a.out. So what I'm going to do now is I'm going to say, I'm just going to type a.out, and that means go ahead now and execute this executable file that I just created. Is there an employee to process? I'm going to say yes. Hours worked 20, pay rate 30. That's going to give me $600, right? Is there another employee to process? Yes. Hours worked 40, rate of pay 15. That's going to give me 600 also. And then I'm done. So I'm going to say no, and then I'm done. Okay. Any questions? Ready for the next example? All right. For the next example, I want to just change this slightly so that I don't have to keep answering yes, yes, yes over and over again every time I have a new employee. I'm just going to say, go ahead and enter the hours worked, and if you want to quit, enter a negative number. So it'll look something like best way to do this. Actually, I think I'm going to cheat here. This is the sort of output I'm looking for, right? Inner hours worked 10, rate of pay 20, and then it just pops right back out and asks me the hours worked again. And then when I want to quit, I just enter a negative number. Okay, so this is the sort of output that we're going to try to get now. I'm going to edit my loop a little bit. Let me take this. Oops, wrong. Yeah. Okay, so I feel like I should probably just stop and let you stare at that for a minute. Let me know if you have any thoughts about it. Otherwise, I'll let you stare for a minute and then we'll give it a run. All right, let's give it a try. So just to kind of babble about it for a minute, I guess, what we're saying here is while hours is greater than or equal to 0, go ahead and go through this process, right? But I'm saying enter a negative number to quit. So in my while loop condition is now keep going as long as hours is greater than or equal to 0. Anybody want to predict what's going to happen when I compile this? Or that's actually kind of a trick question. Yeah, let's just see what happens. So I'm going to compile this, and if everything is okay, it's going to create an executable file. Right, everything looks good. Let me just point out here, before we go any further, that if I was using Visual Studio right now, this would not have compiled. Anybody see why that is? We had this discussion yesterday. No value for hours, exactly, right? We had this this example on Monday. Well, I can't remember if it was this class or the afternoon class, but I tried to show you an example of what would happen if a variable wasn't initialized, and Visual Studio wouldn't let me do it because it wouldn't even compile, right? In this case, you're seeing that here's a different compiler and it's actually saying, fine, no problem, right? But it's a problem. It's just the compiler isn't flagging it. So I have declared hours here. And then the very next time I use hours, I check to see if it's greater than or equal to 0. That cannot possibly be correct because hours at this point, the first time I get here, just has some arbitrary value in there, and it doesn't make sense to check to see if that arbitrary value is greater than or equal to 0. Or to put this another way, if the junk that hours starts out life as turns out to be negative, then the while loop will never get executed, right? So just hold on to that thought, unless that wasn't clear and you want me to try again. But let's just see what happens if I try to execute the executable file now, a.out. Okay, enter hours worked. So what that tells me is we got lucky, and whatever this junk value that was in hours turned out to be non-negative, right? So we got lucky, we got into the while loop. So let's see what happens. Inner hours work 20, rate of pay 30. The paycheck is $600. So far, so good, right? Inner hours work, negative number to quit. Let's do another one. Worked 40 hours, rate of pay 15. Paycheck is $600. That's all correct. Now I want to quit. Is that what we wanted? Just got to ask that question to make sure everyone's tracking with me here. Is that the result that we wanted when I typed -1?
No, it's gonna loop forever.
It's going to loop forever. Okay. Well, perhaps, but at least we know that that's not the result we wanted. What we wanted was we wanted the program to actually stop at that point, right? But instead of that, it's asking me for the rate of pay. So if I'm the user, I'm saying, okay, I want to quit. I typed the -1, and then instead of quitting, now it's asking me for a rate of pay. I don't really know what I'm supposed to type. Maybe if I type another negative number, the program will quit for me. So I'm going to try -1 again. And the amount of the paycheck is $1. And now the loop stopped, right? Okay. I'm super curious. How many of you feel like you totally get what's going on right now? I don't know if you can you do your little thumbs up thing or raise a hand or what, but just curious. You don't have to actually answer the question. Okay, well, I'm not seeing any hands. No. Okay. Good to know. Glad I asked. Let's go through what's going on here. So, let's say that I entered. So we're going to pretend to be the computer here. We're just going through step by step, tracing through our program. Let's say I'm at the point where I entered hours worked of 40. So hours is equal to 40. Then enter rate of pay. Let's say I entered 15. So pay rate is 15. So I calculate the paycheck, 600. The amount of the paycheck is 600, right? So this all makes sense that I'm right here in my output, right? And so now I go back up to the top of my while loop. Hours is still greater than or equal to 0, right? Hours is still 40. And so I'm going to enter the loop again. Enter hours worked, negative number to quit. So now I enter the -1, so hours is equal to -1. But that doesn't mean that the loop stops right here, right? I only check the condition at the very top. So I'm going to keep going until I get to the bottom of the loop. So hours is -1. So instead of just stopping, I get to enter the rate of pay, right? So that's where I was the user and I was confused why it's asking me for the rate of pay. Well, okay, so I enter -1 again. So now hours is -1 and pay rate is -1. So now hours is less than 40. So I'm going to execute this one. Paycheck gets -1 times -1. So paycheck gets 1. Then the amount of the paycheck is $1. And now I go back up to the top and I check my condition. Now the condition is false, right? Because hours is -1. So now the program stops. Okay, good. So seems like, at least for some of you, that's making a little more sense now. Definitely super important that that makes sense. And I might just throw out, actually this has nothing to do with C++, right? The issue we're talking about here, I could have done this exact same example in Python and we would have had the same discussion. But I just want to, I'm going to beat this to death a little bit. This is a really important concept. One way to fix this would be another if statement, right? We could, after we enter the hours, we could put all of this code inside a big if statement that says if hours is still greater than or equal to 0. That's adding another if statement. It's a little repetitive because we already have an hours greater than or equal to 0 condition here. So I'm going to see.
Would it be a do while loop?
I'm going to see if we can come up with a better solution for that, right? But hold on for a minute. You might have to be a little patient here. I'm gonna get to this sort of the long way. And I would just say that without sounding critical or something, I want you to think about the instinct to just kind of fix this by putting an if statement in there is something sometimes we refer to that as putting a band-aid on the problem, right? Let's spend some time figuring out what's going on here, why we had that problem, and what would be the best way to resolve the problem. So I'm going to go back to the notes for a minute here because I talk about this in the lesson. So point number one I want to make right here, a while loop does not immediately stop executing if the condition becomes false somewhere in the middle of the loop body, right? So I think probably you knew that, but it's something that it's important to sort of be cognizant of as you're working through stuff. Everyone okay with that statement? Any questions about what I mean there? Okay. Next thing. The CN statement at which the user might enter the special value, meaning they want to stop executing the program, should come immediately before we check the condition. Does that make sense? Because if the user enters the negative value, then we want to stop immediately. So we should put that statement right before we check the condition. Okay, let's keep going. Let's take another look at the screen output we want our program to produce. If you look carefully, you will notice that we execute this statement one more time than we execute all of the other statements in the body of the loop, right? So if we look back up here, we've got kind of a sandwich, right? Enter hours worked, and then these two lines. And then enter hours worked, and then those two. No, that's the actual output. Sorry, that's not the output we wanted. Here's the output we want, right? If we write the program correctly, the enter hours worked is always going to come out one more time than the other statements that we're working with here, right? Okay, so we actually have a name for that, and I'm not sure if this is a widely known computer science name, but I like it. I learned it 30 years ago when I was taking this stuff, and it kind of stuck with me. I call this a fence post problem because it's like building a fence, right? If you build a fence in a straight line, you always need one more fence post, then you need planks going between the fence posts. Anybody want me to like explain that in more detail, draw a picture, whatever, or are we okay with that? Does everyone understand how this problem is like a fence? Okay. All right. Again, some of this stuff, if this doesn't make sense and you don't feel like asking in the middle of class because you're bashful, please feel free to, shoot me an email or something. Make sure you get this figured out. So here's my conclusion. Because the CN statement at which the user may enter the special value must occur one more time than the rest of the statements, that statement must appear once outside the loop, as well as being inside the loop with the rest of the loop body statements. Okay, so just sort of reasoning about this problem a little bit leads me to this solution, which I think a couple of people have already suggested, but I'm going to ask the question first, and this is called priming the loop. And then I'm going to enter the loop. I'm going to process that one value. That's all of this stuff, right? And then once I'm done processing everything, I'm going to ask the question again. Okay. I this is again, this is what I'm about to say is not a general computer science term. It's just sort of what I call it. So in case you hear me say this, I call this a special value type loop. This loop pattern is your friend, okay? I can't tell you how many times I get students in my super advanced computer science programming classes turning in assignments, or not turning in assignments, but coming to me with questions saying, why doesn't my program work? And the answer is, well, if you had just used a good special value type loop in this situation, it would have worked. So anyway, I'm just kind of beating this to death because I really want you to pay attention to this sort of pattern. The other thing I'll just say is that as someone had suggested, we could do this by just throwing another if statement in there. And there's probably, very smart professional computer programmers that would take that approach. And I'm probably not going to mark you down if you do that instead of what I have here. But I've sort of made my argument for why I think this actually is a better approach than just throwing another if statement in there. Okay, any questions about that example? That's sort of my section on loops, special value type loops. The distinguishing factor of the kind of loop we've talked about so far is that there's no way to know how many times the loop is going to be executed when you start the loop. So in the running of the program, when the computer gets to the point where it's about to enter the loop, there's no way to determine how many times the loop is going to go. Okay, so in that case, you're probably, and sometimes you'll see this, I think actually our textbook may call it a sentinel value loop or something like that. I can't remember, but there's definitely this division of different types. And the deciding factor is whether you can determine when the loop is being entered, how many times it's going to execute, okay? The next kind of loop we're going to talk about is something called a counter controlled loop, or I think the text may call it a count controlled loop. Again, oh, look right here. I can say the text calls it a sentinel controlled loop. Not 100% sure that that's the same text we're using, but let me just back off for a second here and say that, or observe, make an observation. Everything that we've talked about loops, 99% of it hasn't actually been about how do loops work in C++, right? Basically what I'm doing here is I'm saying, okay, I've showed you the syntax for a loop in C++. Let's talk about strategies for using loops, right? So this, 99% of what I've said about loops so far, I could have said exactly the same thing if we were looking at Python code instead. Okay, counter controlled loop is just a loop where when we're running the program and we get to that point in the program, we can determine in advance how many times the loop is going to get executed. So what we do there in that case is, so here's an example of a loop. Well, so this program prints my name on the screen 10 times. I want to do that with a loop instead of actually printing it out 10 times. So my loop is going to look something like this, right? And so I'm kind of gradually refining this code so it gets closer to something that's actually going to work. So what I want to say is, while the number of times through the loop, or while the number of times the loop has been executed, would be a more precise way to say that, is less than 10, keep going, because I still haven't done it 10 times, right? What I'm going to do is I'm going to create a variable named count that is going to keep track of how many times I've been through the loop. So here we go. I'm going to declare count, I'm going to initialize it to 0. By the way, I probably should just do this all in one line, right? Int count gets 0 instead of 2 lines. I think I did this here because I want something I want to demonstrate, but this is how I say while the number of times through the loop, the number of times the loop has executed is less than 10. Count less than 10. So count, I should probably have a comment here saying that count represents the number of times we have executed, the number of times the loop has been executed. Then each time through the loop, at the end of the loop, I increment count to say, okay, we've been through the loop one more time. Also in C++, at this point, instead of saying count gets count plus 1, I should probably just say count plus plus. That's just another way of saying count gets count plus 1. Any questions about this loop? That's the basic counter control loop pattern. Basically, this exact same loop, you can use it exactly the way it is. The only thing that will change is you change the 10 to be however many times you want the loop to execute. And then you change this statement to be whatever you want to have happen every time through the loop. Okay. All right, I think I'm just going to kind of plow through some more examples now. Sorry, time out just for a second. Oh, did anybody besides me get the SSU alert test? Anyway. Okay, and well, let me just say one more thing about this. There are actually reasons why I have chosen certain elements of this pattern. So I'm going to suggest that you start off count at 0, and you'll see why in a couple weeks. I'm going to suggest that you use less than here, not less than or equal to or something like that. And I'm going to suggest that you always do the increment statement as the last statement in the while loop. Okay, so if you just stick to that pattern for counter control loops, you can always just, you don't have to start from scratch, right? You can just copy and paste from right here and then substitute whatever you need to put in there. Okay, I'm just going to go through a few examples now. Write a program that writes your name out n times. So instead of 10, I'm going to ask the user how many times they want it to be written. Basically, that just means instead of 10 in this position, I'm going to put num times in that position. Joe, and answer your question about why I prefer less than instead of less than or equal to, I'm going to ask you to hold off on that. The answer is yes. Okay. But you're going to see why in a couple weeks. Okay. And I'm not saying that I'm saying that should be sort of the default. There are going to be some times when you might want to for some reason. But by default, this should be the more natural way to do it. And I would just say, I guess I could answer that in one more way, and that is to say that it's definitely for experienced C++ programmers and in most programming languages, it's definitely sort of the default, right? And you'll see why within the next couple of weeks. It has to do with the fact that arrays start off at 0. Right, so the way that I work things is that I'm going to be posting the lessons for each week on Wednesday afternoons after my afternoon lecture. Okay, here, next example. You can see that I'm just sort of gradually adding a little complexity to these examples, just sort of one step at a time. Write a program that writes out the numbers from 1 to n, where n is entered by the user. So here we go. into the number you want to count up to. Basically exactly the same pattern again. The only thing that changes is instead of writing out my name, I'm writing out a number. Okay, now I'm going to say that this is one of those cases where it actually might make more sense to start count off at 1 and use less than or equal to here, because we actually want to print the numbers 1, 2, 3, 4, 5, and so on. So let's play around with this a little bit. I'm going to copy this and I'm going to put it into our program. Oh my. Let me fix the indentation here. Okay, so if for some reason you don't want to stick to the pattern that I have showed you, there are a couple different ways that you can change this. One is, well, actually, let me do this. Okay, so this is sort of like the basic program without, but there's a problem, right? Instead of printing the numbers from 1 to max number, it prints the numbers from 0 to max number minus 1. So the question becomes, how do we fix that? And so in the lessons, the way that I fix that is by actually just printing count plus 1 instead of printing count, and that works fine. An argument could be made that it might be better to fix it by starting count off equal to 1 instead of 0, in which case we would just have to change that to less than or equal to. Right? So now instead of count going 0, 1, 2, 3, 4 up to max number minus 1, it's going to go from 1 up to max number. Any questions about that alternate solution? Okay, going back to what we started with. Anybody want to suggest another possible way that we could make this work with instead of changing count to count plus 1? So the other common thing that students will come up with is switch these two statements, right? Yikes. Okay, that would also work just fine. Okay, count plus plus is just another way of saying count gets count plus 1. Okay, it's just a shortcut in C++. All right, so I would say, well, so first of all, yes, we also have plus equals in C++. Well, so let me just say, there's nothing particularly wrong about either of those three solutions. I do want to encourage you to at least have a strong bias towards sticking to the pattern, just because it's going to help you out later on. So there's the pattern. If I want to fix it so that it prints the numbers from 1 to max number instead of 0 to max number minus 1, I can just print count plus 1 instead of printing count. All right, any questions about any of that? Okay, I think what I'm going to do, there's some good examples here in the rest of lesson 4 that you should definitely take a look at. Here I'm adding up some numbers. Here I am averaging some numbers. Here I am finding the small, no, that's the average. Here I'm finding the smallest number. But I just want to use the last few minutes we have here to go over other types of loops in C++. I can't remember. I don't think that you have a do while in Python, but you have while and you have for. Sorry, I can't. My memory is failing me a little bit in terms of Python, but so let's look at lesson 5. So 3 different kinds of loop structures in C++. So now just to clarify, a few minutes ago, I was saying there were 2 different kinds of loops. There were sentinel controlled loops and there were counter controlled loops. That was more of a concept, right? I could say the same thing in any programming language. Now we're talking about actual syntax for loops. In C++, there are 3 different loop types. The one we were just talking about was a while loop. Another thing you can do is you can use a do while loop. Here's the syntax for that. I'm not going to spend a ton of time talking about it. Basically, all it does is it takes the condition and it takes it from the top and puts it at the bottom instead, which really means it's exactly the same loop, except that you don't check the condition the first time. You just automatically do the loop the first time. And then from then on, it's exactly the same as if it had been a while loop. Okay. Anybody want to ask a question about do while loops? I guess I would say my strategy about do while loops is I rarely use them. The only time I'll ever use them is if I'm trying to use a while loop and I realize, this might actually come out to be a little more clear, maybe a little more succinct if I switch it to a do while. And so maybe I'll write it both ways. I'll write it using a while loop, write it using a do while loop, look at the 2, see which one is easier to read and understand, right? In my experience, probably 90% of the time, the while loop is either better than or equal to the do while loop. So you're probably safe if you just stick with do while. I'm sorry, if you just stick with the while loop. Now that I just said that, I'm thinking, I think in assignment 2, I might have actually used a do while. But anyway, if you just use while loops, you'll be fine. If you want to try out the do while loop in a particular situation to see if it helps your code, that would be even better. All right, here's another way of saying sort of the same thing, right? Use a do while loop if you know the user will want to execute the loop at least once. Use a while loop if you aren't sure. All right, I think that's all I'm going to say about do while loops for now. There's a couple of examples in here in the lessons that you can go ahead and take a look at to see how they work. So otherwise, I'm going to go on and I'm going to look at for loops. And basically, and I promise I'm not going to do this thing with the lessons for the rest of the semester, okay? Just during the review, I'm going to be depending a lot on just scrolling through the lessons, but you won't see me do that very much after the first few weeks. Okay, basically a for loop is a construct in C++ that makes it so that a counter-controlled loop is clearer, easier to read, and get all of the information you need all at once. Okay, so if you've got this counter-controlled loop, and this is the basic pattern or template for a counter-controlled loop, right? started off at 0. So we're doing 3 things here. There's 3 parts to this pattern. There's initialization, there's a test, and there's an update. I'm updating the value of the count. Okay, those 3 things are not really part of what's going on inside the loop. They are the logistics of the loop itself, right? So what we do in a for loop is we just take those 3 items and we put them smack all in one place right at the very top of the loop with semicolons in between, right? So the way a for loop works is we open paren, put the initialization you want, put a semicolon, put the test, put a semicolon, put the update, put the close paren, you're done. Okay. Now I could stop there. That's all you need to know. You now know everything you need to know about for loops, right? Let me just make a few observations that might be helpful. First of all, the initialization is just going to happen one time before the loop starts, right? So students get confused sometimes because it's sitting there in the header of the loop, but that doesn't mean it's getting executed more than once, okay? It's an initialization that gets executed one time before the loop starts. The condition or test is pretty much what you'd expect, right? It's there at the top of the loop. I'm going to test that condition every time I get to the top of the loop. When that condition turns false, I'm going to exit the loop, just like it was when it was in the while loop. Nothing too surprising there. This one really throws students off sometimes because it's hard to remember that that is actually happening as the last statement in the loop, right? So even though it's sitting there at the top of the loop, it does not get executed until you've hit the bottom of the loop. You've executed all of the statements in the body. You're ready to go back up to the top of the loop. Now you do the update statement. Okay, so just be careful about that. The other thing I'll say, and again, I could stop there and you could use a for loop just fine. And in some ways, I'd rather not tell you the rest of what I'm about to tell you because it can lead to some really ugly stuff. But it turns out that the for loop is actually extremely flexible. I can put any statement I want right here, and it just gets executed one time before the for loop starts. As a matter of fact, I can put as many statements as I want there if I put commas between them. Okay, so what that means is I could take my entire program from above the for loop if I wanted to for some reason, and I could stick it right here where the count gets 0 is and just separate the statements with commas, and that would still work. Okay, not suggesting you do that, just want to make sure you're aware of what you might see. Okay, it's not actually uncommon for programmers to put like maybe 2 or 3 different initializations here, separated by commas. Same thing over here, right? So hypothetically, I could take the entire body of my for loop, put all of those statements right here, separated by commas, and everything would still work fine. Okay, not suggesting you do that, just letting you know that's a possibility. So what goes in front of the first semicolon is a list of statements that gets executed before the for loop starts. What gets put after the second semicolon is a list of statements that gets executed each time through the loop at the bottom of the loop. Nothing too surprising here. What goes between the 2 semicolons is just a logical expression that gets tested every time through the loop. Okay, so I'm telling you all of that just so you know, in case you see that in somebody else's code or something. My strong recommendation is that you always just follow this pattern. Whatever your loop variable is here, it always occurs in all three of those parts of the header. Okay, I think that's pretty much all I want to say about for loops. There's some examples here, so I do the same examples I did before, using a counter controlled loop, while loop. The other thing I'll say is that now that we have a for loop, when you have a counter control loop, you should use a for loop, not a while loop. Even though we did all those examples of counter control loops and earlier today, in lesson 4, you'll see them. I did all those counter control loops using a while loop. Now that we know about for loops, you should use that. In fact, you'll find that in the style conventions, I say something like, use a for loop for counter control loops. Do not use a for loop for any other kind of loop. Okay. That's not necessarily how all programmers would do things, but that's how I would do things. That's how we're going to do things in this class. And I think it's kind of nice because it gives you a nice, easy rule for knowing when to use a while loop and when to use a for loop. Okay. Any questions about anything we've talked about? All right, let me just stop recording here.